Hi, Geometry. I'm going to go over our in-class review centers half sheets with you. So let's take a look at this first one. First of all, I hope this diagram looks familiar in number one. This is a rotation. We rotate, we could use our patty paper and K as my center of rotation, and we would rotate H onto F. We would rotate F would come down and be on top of H, and E would correspond to G. So this is a rotation. So I know that my H goes to F and F goes to H. I can also see it up at the top where it says triangle HEF. Since it's the image after rotation, they'd be congruent to triangle FGH. So H goes to F, E goes to G, and F goes to H. So they put this in order of FGH. So we just talked about how my F goes down to my H. Those are my double red arcs I'm looking at. G goes to E. Those are my green triple arcs I'm looking at. And H goes to F. Those were the single black arcs I was looking at. So now angle, KHE. Go find it. That's this single arc angle right here. And so it's congruent to the other single arc angle, and that would be K. Sorry, I got to start with my corresponding parts. So K, F, and then G. So then it says statement EH is segment EH is congruent to what segment? So let's go find EH. It's this segment right here from E to H. And be careful, E goes to G. So it would be congruent to GF on the other side. Make sure you write it in GF order. Because this is a rotation, we have to remember to flip-flop when we're working with F and H. Use the congruence statement to fill in the missing things. So angle E must go with angle H. FE would be the second letter and then the first. So let's go get GH. That's my second letter and the first. And then triangle FEI. So if I'm going to match my order, F was in the middle, so I'm going to start with G. E was first, so then I'm going to go to H. And I goes to I. So that would be my first two. So these problems, I'm supposed to say why they're congruent. So this is an angle, the included side, and an angle, congruent to another triangle's angle, included side, and an angle. So this is an example of angle, side, angle. 4 is an example of side, side, side. No angles marked anywhere. So on 5, I do have to mark my vertical angles. Now, I'm missing a third piece of information. There's just one angle on one side. So this one is just not congruent as given. There's nothing I can do with it. So now let's take a look at this one. Notice the side that's marked. This is not the included side. The included side would be the one in between the two angles, and it's not marked in this diagram. So when I write this, I cannot write the S in between the two A's because my side that's marked is not in between the two angles. That'd be this side right here, and like I was pointing out, that's not the one that's marked. So when I write this, I can write it as angle, angle, side, or side, angle, angle. I have two angles and a side, but I can't put the S in the middle. This is one of my ways, angle, angle, side. This is how I typically write it, but they're both the correct answer. So let's 3. So on this page, we're reviewing some of our isosceles triangle problems. You have to remember that a triangle always adds up to 180 degrees. We find that useful when we do these problems. So in this first problem, I need to figure out what are my base angles. Well, my base angles are the green angles. They are congruent to each other, and they are across from my red congruent side marks. My X then would be my vertex angle, and my X is made up of my two congruent sides. So in this problem, I know that I would have two angles that are 51 degrees. So you could do your math however you'd like, but I'm going to do 180 minus 51 minus 51. Some of you like to multiply 51 by 2, and then you subtract from 180. However you'd like to do it is fine, but we're going to get 78 degrees for x then. So let's take a look at number 8. On number 8, let's go find my base angles. My base angles this time are my green angles across from each other here. My red tick marks point. This red tick mark is pointing to this angle, and the other one's pointing to this one. That leaves us 72 degrees to be my lone vertex angle. So I want to figure out x. So let's take away the 72 degrees and find out how many degrees are left in my triangle. So there's 108 degrees for my two green base angles. So I'm going to divide that by 2, and there's 54 degrees then left for these two angles. So this x would be 54 degrees. So number 9 works just like number 8. My J and angle K are my base angles across from my red tick marks. My 82 degrees is made up of the red tick marks. That's my vertex angle. So my 180 minus my 82 is 98. Divided by 2 is 49 degrees. So the measure of angle K is 49 degrees. Let's take a next page. So on this page, we need to mark our given. Step 1. These steps are on page 10 of our packet. And step 1 was to mark the given. So AC is congruent to EC. So this is my AC, and this is my EC. Mark that. And then let's mark BC congruent to DC. Let's mark those with 2. And then finally, step 2 then is to mark the things that you know. Well, I know my vertical angles, so I'm going to mark them. And I'm going to look, step 3, at my diagram, and it's congruent by side angle side. So it's congruent by side angle side, and when I match up A goes to E, B goes to D, and C goes to itself. Okay, so number 11, step 1, let's mark M and Q. Let's not mark anything else, just M and Q. So that's what I'm going to mark with my blue one. And then the next part of the given says N is the midpoint of MQ. That's all it says. So this is MQ. N is the midpoint. That means it splits it in half. That's the definition of a midpoint. That's what a midpoint does. It splits a segment into two congruent parts. So that's all I can mark from the given, just those two things. So then next, step 2 is I think of what I'm supposed to know. Well, that's like reflexive side and vertical angles. So I have my vertical angle here at N. And when I mark that, I now am ready for step 3. When I look at my diagram and I decide why my triangles are congruent. And they're congruent by angle, side, angle. So now I just have to write the right parts. So L goes to P, N goes to itself, and M goes to Q. So let's take a look at the next one. The next one says RS congruent to RU. So let's mark those two. And then it says TS congruent to TU. So let's mark those two. And now step 2. I mark the things I'm supposed to know. So hopefully at this point, you're thinking about that reflexive side right there. So step 3, I think of why these two would be congruent. And so it's obviously side, side, side. There's no angles marked anywhere. I'm not supposed to mark any angles. So this is side, side, side. And when I match up S, it goes to U. R goes to itself because this is a reflection, and T goes to T. I know it's a reflection because the green side folds onto the green side, the red onto the red. So now, this problem right below this, it's the exact same diagram, but I have a different given. So I'm going to mark it differently in step 1. So this part of the given tells me the RT. So go get a visual. Where's my RT? Oh, that's this line right here. It's the bisector of angle SRU. Well, we've been talking in class. What does an angle bisector do? Just like a midpoint that splits a segment apart, an angle bisector splits an angle into two equal parts. So let's mark both sides with just a single arc. So now let's go look at the second part of the given. RT bisects STU. So now go find your STU. That's this over here. And RT is bisecting that red angle. So I know it splits it into two congruent parts. That's the definition of an angle bisector. So if I was going to write a proof with this, the reason for the blue arcs would be the definition of an angle bisector. The reason for the red arcs would be definition of an angle bisector. And then don't forget step 2, that's when I mark what I'm supposed to know, and that's my reflexive side. So this one is angle, side angle. It's also a reflection. My blue goes onto the blue, the red goes onto the red. So I would say R goes to R, S goes to U, and T goes to T. Okay, so let's take a look at the next page. So we proved that opposite angles in a parallelogram are congruent. So I know that if F is 95, for instance, D is also 95. They are opposite angles. So next it says to find all the remaining angles. There's a couple ways to do this. What we talked about in class is this is a four-sided figure. It's got a total of 360 degrees. So if I add up my 95 plus my 95, I get 190 degrees are my two green angles. Let's subtract that from my total for the whole thing. And I get 170 degrees for angles C and E. So C and E add up to 170. Let's divide that by 2, and I know that C and E is 85 degrees. And it makes sense because D and E, if I added them together, I would get 180 for those two, 180 for the other two. That's my 360 again. So on number 15, L is across from J. They are opposite, so I know L is 46 degrees. And if I want to find the other ones, then 46 plus 46 is 92 degrees. So let's find out what's left over for the other two angles. 360 minus 92 gives me 268. And when I divide 268 in half, I get 134 degrees for each one. And it makes sense because 46 plus 134 would add up to my 180, half of my quadrilateral. Let's take a look at this next page. So it says this is a kite. I can see that, the two congruent sides. It says angle WZY. So often it's good to go look and find W to Z to Y is this red angle over here. And it says that angle is 84 degrees. So if that's true, we talked in class last week how these two triangles are congruent by side, side, side. So my corresponding parts would be congruent. So in this kite, I know if Z is 84, then X is 84. What does it say next? ZWX. Which one? ZWX. Oh, this is this big blue one right here. This ZWX is equal to 108 degrees. So the whole thing is 108 degrees. So my WY is my angle bisector, splitting my quadrilateral in half, but also splitting my angle W in half. So if I take my 108 divided by 2, I get 54. So 54 degrees on this side, 54 degrees on this side. Now this problem was asking me to So this problem asks me to find the measure of XYW. Let's go find that, XYW. So, well, if I think of this, if I could get my highlighter back, if I just think about just this half being a triangle, this guy right here, then my three angles have to add up to 180 degrees. So I'm going to use that. 180 minus the 54 minus the 84 would leave me with 42 degrees for angle XY W. So let's take a look at the next problem, which is done in a very similar way. It says that angle Z has a measure of 121 degrees. Okay, so that means X must be 121. Let's go ahead and write that in. Then it says angle XYZ. So XYZ, let's go find that. That's X. Oh, this is that whole thing right here. The whole thing. The whole thing has a measure of 40. Okay. Well, it's split by WY. So it's split into, I'm going to call this 20 on this side and 20 on this side. Okay. And so what was this problem asking us to do? Find the measure of angle ZWY. So ZWY is this guy right here. So again, I'm going to think of half of this kite as being a triangle. So 180 minus the 121 in Z minus the 20 and half of Y. And I'm getting 39 degrees for this blue angle right here. Okay, let's take a look at this page. Oh, it's one of my proofs, my favorites. So again, page 10 of our packet is our first notes on proofs. And there's a video for pages 10 and 11. And there's also a video for pages 12 through 15. All of those are proofs. It's all a good use of your time to rewatch those if you need them. And if you want those pages blank again, if your packet's kind of messy and a lot of lines are erased, you can print additional pages from our folder, our Unit 2 folder. The packet's in there blank. You could print just one page or all the pages, whatever you need. So step 1 on page 10 says to mark the given. So E is the midpoint of AB. So I'm going to mark that. And it means that E splits AB in half. So AE and EB would be equal. That is definition of a midpoint. Okay. So then let me get a different color. It says E is also the midpoint of CD. So find CD, and E is splitting that in half too. Again, that's also the definition of a midpoint. Step 2 is to mark what you know. Well, I also know these vertical angles at E. So then step 4 is to look at it and determine, or step 3, sorry, to look at and determine why they're congruent. Well, these two triangles are congruent by side angle side. Now and only now you're ready to go fill in the proof. So the first line is always the given. And if you notice, this completely matches what I've underlined above. That was my given. So my first one is the given. So this was my given. And then let's look at the next two lines. So first of all, I'd like to point out this line right here where it says AE is congruent to EB. Those are the segments I marked in blue up above. That's my AE and my EB. So that was definition of a midpoint. So was what I marked in green. And you'll notice that segments are not listed in this problem. So I'm going to list CE now, congruent to DE, and those are my two green ones up above. So now I have a blank line. I have something that I haven't talked about, and that's my red vertical angles. Those haven't been mentioned anywhere. So I need to add my congruent vertical angles right here. Vertical angles are congruent. So you can name them either way. I'm going to name the one on the left AEC. So then the one on the right, A corresponds to B, E goes to E, and C goes to D. Now the next line is two triangles being congruent. Well, these two triangles were congruent by side angle side. And I know in a proof, the proof is always the very last line. So I'm going to write angle C congruent to angle D. And I know that now. If my two triangles are congruent in the line above, then all 6 parts are now congruent. So yes, this C and this D in my diagram are now congruent by CP, Everything else, and I'm going to erase those now, and everything else is now marked up and congruent by CP. So let's take a look then at the next problem. So the next one, we've worked with this diagram quite a bit. Again, you can only mark what your given says. So my given says that RT bisects SRU. Go to SRU, and RT is bisecting that. So let's mark my two halves equal, and that is the definition of an angle bisector. I'm going to be using that in my proof. In fact, I can see it right here. SRT, that's up in red with the 2 arcs, and URT is also up in red with the 2 arcs. That's definition of an angle bisector. But I'm not supposed to fill that stuff in until I'm done with step 1. Step 1 was to mark my given. So I still haven't marked my STU. So STU is this big angle over here. Again, if RT is bisecting it, that means the 2 halves are equal. The 2 halves are congruent. That's the definition of an angle bisector. Step 2, I have to mark what I know, and I know my reflexive side. So now I'm ready to determine step 3, why are these 2 triangles congruent? That's angle, side, angle. And now I'm ready to write this up. So step 1 is always my given. So let's write my RT bisects angle SRU and STU. So the next 2 lines kind of go together. These are my angles that are bisected, my red ones and blue ones. So since SRT, my red ones, were already written there for me, it must be the blue ones I have to add myself. So in the line up above, we're going to add my STR congruent to UTR. And that was also marked because of the definition of an angle bisector. Now, when I write my reflexive property, my green reflexive property, I have to keep R and T in the same order. It doesn't really matter if you write RT or TR, but it does have to be the same on both sides because this is a reflection, not a rotation. So then I determine my triangles are congruent by angle, side, angle. This is a triangle congruent to a triangle. It's going to be one of my 5 ways. And then I know that my last line is always what I'm trying to prove. And I also know that if it's 2 angles or 2 sides congruent, it must have been CP, because they were corresponding parts of 2 congruent triangles. Okay, let's take a look at 20. In number 20, it says AB is parallel to CD. So don't mark the sides, only mark the top and bottom. That's my AB and that's my CD. Don't mark anything else. AB is congruent to CD. So now I'm going to mark the top and the bottom congruent. Don't mark anything else. So now, step 2, I have to mark what I know. And what I know is my reflexive sides. And also, what I know here, whenever I have parallel lines, I want to draw my Z. And when I have parallel lines, I have alternate interior angles. And my alternate interior angles are in my Z. So in this problem, it's these 2 angles that I've marked with a single arc in green. So now I look at my diagram and I figure out why my 2 triangles are congruent. And I see a side, an included angle, and a side. So this is my side angle side with the included angle. And I'm all ready to write this up. So number 1's a given. So let's put our AB congruent or parallel to CD first, and then AB congruent to CD second. Alternate interior angles. Oh, okay, those are the green ones I marked. So I'm going to go grab my green. And you can write it in any order. I'm going to write BAC. As long as that B is in the middle, you could write BAC or CAB. It doesn't matter. But the next one, if I'm going to write corresponding parts, I have to write angle DCA. This is a rotation, so my A and C are going to flip-flop. Now the next line is left completely blank, and I'm trying to think what goes there. And I realize I've never added my reflexive side anywhere. So this is where I'm going to put my A, C, or CA. Doesn't matter how you write it. But when I write it on the other side, I'm going to flip-flop them because this is a rotation, not a reflection. That's my reflexive property. So the next one is two triangles being congruent. So my two triangles were congruent by my side angle side. Side angle side. And I know that then my two sides, my AD and BC, will be congruent by CP, CTC. They are now corresponding parts of two congruent triangles. I hope this was helpful. Please bring any questions you have to class.